Hello dear students, we are seeing the problems, numerical problems related with the Coulomb's law in electrostatics. In this video also we are going to see some numerical problems related with the Coulomb's law. First let us see this problem. See the question. A certain charge Q, capital Q, is divided into two parts, small q and capital Q minus q. How should the charges capital Q and small q be divided so that small q and capital Q minus q placed at a certain distance apart experience maximum electrostatic repulsion? This is a question. Options are given. See, option A, capital Q equal to small q by 2. Option B, capital Q equal to 2 small q. Option C, capital Q equal to 4 small q. Option D, capital Q equal to 3 small q. Okay, see the question. First, there is a charge capital Q which is divided into two parts. Okay, from this capital Q, a part is separated, that part is small q. So if we take a part from capital Q, then the rest of the charge will be what? Capital Q minus small q. Okay, now we are calculating the force between capital Q minus small q and this q. Okay, originally there is only one charge. Okay, from this charge a part is removed, that part is small q. So small q is the new part. Okay, so the rest of the charge will be capital Q minus small q. So now we have, there are two charges. We have to calculate force between these two charges. Let us assume the distance between these two charges is r. The question is, what should be the maximum, what should be the, in what way the capital Q is divided into two parts like this, so that the force between them will be maximum, the electrostatic force will be maximum. That is the question. Okay, now see, the force between these two charges, according to Coulomb's inverse square law, we know F equal to K, the constant, which is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by R square. This is the Coulomb's inverse square law. Here F equal to, let us keep the K as it is, and instead of Q1 we can substitute capital Q minus small q, into instead of Q2 we can substitute small q. Okay, by distance r square. The question is, the force should be maximum. The force should be maximum. So the condition is, force is maximum, it should be maximum. Okay, so in what way this q should be divided into two parts? That is the question. So the basic condition here is, if the force is maximum, then the df by dq will be 0. This is a condition for obtaining maximum force. This condition you have to remember for this type of problem. You should remember this condition, df by dq equal to 0, which means d by dq of f, that is we have to differentiate f with respect to q, the charge q. Why it is equal to 0? If f is maximum, maximum means it will be some value, particular value, particular number, that is a constant. So if it is a constant, if you differentiate that constant, you will get 0. That is the concept behind it. So df by dq equal to 0, which means f is maximum. Okay, so now let us apply this condition here. So instead f, we have to substitute this. So d by dq of, instead of f, substitute this k into q minus small q into small q divided by r squared. Okay, this is equal to 0. According to our condition, this is equal to 0. Let me erase the question now. Now see, you differentiate this with respect to q. First let me just multiply this q, okay, with the q minus q. So what we will get, d by dq of, still we have d by dq, okay. We haven't started differentiation, just we are multiplying this q with this capital Q minus small q. So k into, see, capital Q into small q, what, capital Q into small q minus q into q squared divided by r square, which is equal to 0 according to our condition. Now we can differentiate. See, this k is constant, r squared is constant, so that is taken outside, k by r square. Now you differentiate these terms, okay, with respect to q. If you differentiate q, capital Q into small q, see, capital Q is a constant, okay, so you keep it undisturbed, capital Q, and if you differentiate this small q, you will get, if you differentiate this small q with respect to q, you will get 1 minus, if you differentiate this q squared with respect to q, you will get 2q, okay. R squared already we have written, equal to 0. Now see, this k by r squared, you take this term to that side, what you will get, 0 by k by r squared, it will be 0. So q into 1 q minus 2q equal to 0 by k by r squared, that will be 0. So capital Q minus 2 small q equal to 0. It means capital Q equal to 2 small q. This is the relation between capital Q and small q, okay. So what is the correct answer out of these options given? Capital Q equal to 2q, so this will be the correct answer for this question. So we should know this condition, df by dq equal to 0. This condition we should remember, okay. Please make a note of it. Then we will move to next question, next numerical problem. Now let us see the next question. See the question, force between two point charges q1 and q2 placed in vacuum at r centimeter apart is capital F. Force between them when placed in a medium having dielectric, that is dielectric constant, medium having dielectric constant, here constant is missing, dielectric constant k equal to 5. Actually this should not be k, because k represent 1 by 4 pi epsilon naught. So actually it is not k, it is epsilon r, dielectric constant of the dielectric medium. At r by 5 centimeter apart will be what? Options are given. Option A f by 25, option B 5f, option C f by 5, option D 25f. So here what is given? First q1, q2 are placed in vacuum. First the two charges q1 and q2 are placed in vacuum at a distance r centimeter. So here the distance is r centimeter. Now the force between the two charges is F. It is given, force F equal to what? K into q1 into q2 by r square. We know k is 1 by 4 pi epsilon naught. Okay, this is the basic formula, Coulomb's inverse square law. This is the first case given in the question. Next, second case, force between them when placed in a medium. Now the same two charges are placed in medium having dielectric constant. This is not k, actually this is epsilon r, dielectric constant, or relative permittivity of the medium. So relative permittivity of the medium is called dielectric constant of the medium. So epsilon r equal to 5. So now the two charges are placed in medium of epsilon r equal to 5, and see the separation of charges is r by 5 centimeter. That is the distance between the charges now, r by 5 centimeter. So now so r by 5 centimeter means the charges are placed little close to each other. So q1 q2, now the distance between them is only r by 5 centimeter, but the charges are placed in the medium, some medium whose dielectric constant, that is relative permittivity epsilon r is 5. Epsilon r is 5. Okay. Now what is the new force? This is force in vacuum or free space. This is force in medium. Fm is asked. You know the formula, force in a medium, Fm equal to what? 1 by 4 pi. Instead epsilon naught, here we have to put epsilon into epsilon r. Okay. Then same charges q1 into q2. No change in the magnitude of charges, q1 into q2 by r square. Now not r, now the distance is r by 5. So r by 5 whole square. Instead of r square, we have to put r by 5 whole square. We want the new force, that is force in medium. So this is equation number 2. Now 2 by 1, equation number 2 by 1. So Fm by Fo equal to, you divide this by this. Okay, if you divide this equation number 2 by equation number 1, what you will get? This 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, they get cancelled. Okay, q1 q2 they get cancelled, and see here what will remain? Fm 1 by epsilon r will be there, 1 by epsilon r by what? R square. R squared by 5 square was 5 square what? 25. So r squared by 25. Okay. Into reciprocal of this, because we are dividing. So instead of dividing, we can multiply by its reciprocal. So what is remaining here? R squared. 1 by r squared. 1 by r squared is there. Now we can write r squared by 1 reciprocal. So what is there? R squared, they get cancelled. Remaining this 25 will go to numerator 25. Okay. What is the value of epsilon r? Epsilon r value is given in the question, 5. So instead of epsilon r, we can put 5. So 5's are in 25. We want this Fm. Okay. See the right hand side, only 5 is there. So if you do the cross multiplication, you will get Fm equal to 5 times of F naught. This F naught is given what in the question? F naught is nothing but this F. Okay. So Fm equal to 5 times of F naught. So the answer is Fm equal to 5 times of F naught. That is Fm equal to 5F, which is the answer, this option. This is the correct option. Okay. So already we have discussed this concept while talking about the Coulomb's inverse square law. Okay. So this is a simple problem. Make a note of it. We will move to next question. Let us see the next question. Question number 5. 4 charges equal to minus q placed at the 4 corners of a square, and a charge small q is at its center. If the system is in equilibrium, the value of small q is. We want to find the small q. Options are given. Okay, option A, option B, option C, option D. See the options. Now let us solve this question. Find the answer. 4 charges equal to minus q, minus capital Q, placed at the 4 corners of a square. So there is a square. At each corner there is a charge minus capital Q. Here also minus capital Q. Here also minus capital Q. Here also minus capital Q. Let us name the corners. This is A, this is B, this is C, this is D. Okay, and one more charge small q is placed at the center of the square. So this is the center of the square. Let us name the center O. Here the small q charge is placed. The question is, if the system is in equilibrium, what is the value of small q? Okay, the system is in equilibrium. They have said that in the question, the system is in equilibrium. Then what is the value of small q? System is in equilibrium means no one charge should move from the place as shown in the figure. Okay, this minus q should be at A, at the point A. This minus q should be at the point B. This minus q should be at the point C. This minus q should be at the point D, and small q should be at the point O. So this setup should not be disturbed. Okay, then only we can say that this system is in equilibrium. Okay, so how first what is the condition for the system is in equilibrium, which means the net force acting on the charge, each charge should be 0. See, if this charge is in equilibrium means the net force acting on this charge should be 0. If this charge is in equilibrium means the net force acting on the charge is 0. That is the condition. So in this system, in this square, we have 5 charges. The force experienced per each charge, that is the net force experienced per each charge, should be equal to 0. That is the condition. Net force means, see, we have 5 charges. If we choose any one of the charges, this charge will experience force due to all the 4 charges. If we choose this charge, this will experience force due to all the 4 charges. Okay, so there are many forces acting on particular charge, that the resultant of force or the vector sum of the forces should be 0. Okay, if you choose any charge, the vector sum of all the forces acting on particular charge should be 0. Then only the system can be in equilibrium. This is the condition. So now let us with this condition we can find the value of this small q. First see these 4 charges are identical, minus q, minus q, minus q. Okay, so if you consider any one of these 4 charges, the same thing, same logic can be applied to all the other 3 charges. Okay, right. So we will come later for this minus q charges. First let us see the small q which is placed at the center of the square. See, this small q should not be disturbed, which means the net force acting on this small q should be equal to 0. How many forces are acting on this small q? See, this minus q will attract this small q in this direction with some force. Simultaneously, this minus q will attract this small q in this direction. These 2 forces are equal because same magnitude, minus q, same distance. So these 2 forces will be equal and opposite, so they cancel each other. Similarly, this minus q will attract this small q. This minus q will attract this small q with the equal force but opposite in direction, so they will cancel each other. Okay, so what we can conclude, this small q is in equilibrium provided all the other 4 charges are at rest. Okay, but see, what is the problem here? If you choose, just now we have proved this small q is in equilibrium because the net force acting on the small q is 0. Okay, now come to all other 4 charges, minus q, minus q, minus q. See, if you choose these 2 charges, see, they are like charges, minus q, minus q, so they will repel each other. Okay, so they cannot be at rest at these 2 points A and B. they cannot remain at rest, because they will experience repulsive force, so they will be thrown away. Similarly, if you choose these two charges, they will repel each other. Similarly, these two charges, they will repel each other. These two charges, they will repel each other. Okay, this is a nature, but though they experience the repulsive force, they should remain stationary, which means the net force acting on particular charge should be 0. Okay, how? That is what we have to prove. If now let us choose this charge minus q. In the beginning I said, if you choose any one charge, if you prove that the net force acting on this charge is 0, then the same thing we can apply for all the 3 charges. So now let us choose any one of the 4 charges. Now let me choose this charge at D. Okay, how many forces are acting on this minus q? This minus q will push this charge, this minus q, in this direction. So that force due to the charge placed at A, that is FA vector. Similarly, this minus q will push this minus q. So this force will be, see, force due to this charge placed at C. So this force will be FC vector. And in this direction there are 2 forces are acting. What? This minus q will push this minus q in this direction. Okay, this minus q will push this minus q in this direction, that is force due to this charge placed at B. So FB vector. And this plus q, small q, what it will do? This small q will attract this minus q in this direction, that is placed at O. So this force is FO. So now the condition is for this minus q to be stationary, to be in equilibrium, the net force of the net value or resultant of all these 4 forces should be 0. That is the condition. From that condition only we can find the value of small q. So now what we can say, see, these 3 forces FC, FB, FA, they are acting along in this direction. Only one force FO is acting in the upward direction. So the resultant of all these 3 forces should be equal to this upward force. Then only this charge can remain stationary. Okay, the total of the vector sum of all these 3 forces should be equal to this charge. Okay, so this charge can be at rest or stationary, or it can be in equilibrium position. So that is a condition. So what? FC vector plus F orderly, we can write FA vector plus FB vector plus FC vector equal to what? FO vector. Okay, see, these 2 forces FC and FA, they are equal. They are acting in different direction, but they are equal in magnitude. Because first let us write the values, then we can know how they are equal. See, what is the value of FA? Here let me write FA equal to, only I am writing the magnitude, K into, K is a constant, 1 by 4 pi epsilon naught, Q1 into Q2. So what? If you multiply these 2 charges, minus into minus plus, and Q into Q, Q squared. So Q squared by, what is the distance? Let us assume the side is A. Each side of the square is A. So instead of R squared, we can put A square. Okay, distance between these 2 charges according to Coulomb's inverse square law. Similarly, what is the value of F? This is FA. Similarly, FC also. FC, this is FA. Similarly, FC also, you will get same value, K Q squared by A squared. Okay, what is the value of FB? FB is the force due to this charge. So constant K will be there, and this minus Q and minus Q. that is q1 into q2. So q squared divided by what is the distance between these 2 points, B and D. What this side is A, this side is also A. So by applying Pythagoras theorem, this side, that is BD, will be equal to what? Here I am writing BD squared equal to A square plus A square, which is equal to 2A squared. So BD square equal to 2A squared. So BD equal to square root of 2A squared. So BD equal to A square, square root of A square A, then root 2 will be there. So BD, this distance will be A root 2. So here instead of R I am writing A root 2 instead of R. But in Coulomb's inverse square law, what is the formula? Here R square should come, so square. Similarly, FO vector, what is the value? Let me erase the options. Okay. FO vector. FO vector, that is magnitude of FO. FO means what? The force acting on this minus q due to this small q. So constant k is there. Q into q. Just you see the value alone, don't see the sign. Okay. Capital Q into small q, that is q1 into q2 by r squared. What is the distance? This distance is a root 2. So this is half of this distance. This is a root 2. This is half of a root 2. So a root 2 by 2. This is r, distance between these two charges. So r squared by Coulomb's inverse square law, here r square should come. So square. So what is the value? Here k q squared by a squared root 2 square 2. So 2a square will come. Here what? K into capital Q into small q by a square root 2 square 2 by 2 square 4. So you will get a square by 2. So this 2 will go to numerator. 2k capital Q small q by a square. Okay, this is FO. Now see, let me erase this diagram and all these things. What we have written here, this FA, because A, this is the diagram. A is here, B, C, D. Okay, this is FC, this is FA, okay, and this is FB, this is FO. Okay, see in the FA and FC, what is the equation we have written here? FA vector plus FB vector plus FC vector equal to FO vector. Okay, see FA and FC. FA and FC, they are equal in magnitude, but acting in perpendicular directions. Okay, they are acting in perpendicular directions. So what is the resultant of these two values? A resultant of these two vectors, because we cannot simply add. Okay, what is the value? They are vectors. If two vectors are acting in perpendicular direction, the resultant of two vectors formula, r equal to square root of p square plus q square. Okay, that formula we can apply here. So this FA and FC, if you add these two vectors, you will get square root of, both are equal. So we can write what? FA square plus FC square. FC also equal to FA in magnitude. So here we can write FA itself, FA square plus FB, the magnitude alone, equal to F4. Okay, so you will get FA square plus FA square, 2FA square, 2FA squared plus FB equal to F4. Okay. FA squared, if you take square root for FA square, you will get FA, then root 2 will be there, plus FB equal to F4. Now substitute the values. FA value K into Q squared by A squared. The root 2 is there, so root 2 plus, what is the value of FB? KQ squared by 2A squared. KQ squared by 2A squared equal to F4 value 2K capital Q into small q by A squared. Okay. Now see this K in all the terms K is there, so we can cancel K. Then what else we can cancel? This Q, here one Q, here one Q, we can cancel. Then in the denominator, see in all the terms A square is there, so we can cancel A square. So remaining things here Q into root 2 plus here Q by 2 equal to 2 into small q. Here we want this small q, so small q equal to what? Here 2 is multiplying, so if you bring this to this side, it will go to denominator or division. So A root 2 by 2 plus q by 2 into 2, 4, q by 4. Here q is there, this is not A, q. Okay, so we can write what in the options. This is the answer, but from the options given, we have to choose, we have to modify this. In the option q by 4 is there, q by 4 we take q by 2 q by 2 or q by 4, q by 4 into 1 plus 2 root 2 is there, so we can write what? Q by 4 into 1 plus 2 root 2. Q by 4 is taken common. Here what? If you multiply this into 2, multiply by 2 and divide by 2, you will get 2q root 2 by 4. So q by 4 is taken outside. Rest of the things was here q by 4 taken outside, so here 1 will be there, that 1. Then here 2 root 2 will be there. So this is a correct option. Small q value q by 4 into 1 plus 2 root 2. Okay, so you should know this concept. This is a concept. All the other things are mathematical steps, mathematical knowledge. This is a concept of physics. This you should know. Okay, with this we wind up this class. Still we have to see many problems related with the Coulomb's inverse square law, that we will discuss in next video. Okay, thank you.